Objective 3. Interpret density histograms. For a relative frequency histogram, the height of each bar is the relative frequency of the bar's class. Now, for a density histogram, the vertical axis has units called density, so that the area of each bar is the relative frequency of the bar's class. So, for example, the data below gives the scores received by a class on their first test. The relative frequency histogram and the density histogram are constructed for this set of data. So let's take a look down here. So on the left-hand side, this is the relative frequency histogram of these scores at the top. And this is a density histogram of test 1 scores. Now let's take a look at the first one here, the relative frequency histogram. You can see that we have our classes. Remember that the vertical axis is the relative frequency, and the horizontal axis is the points, and it's going from 30 to 110. So the class between 30 and 40 has 0.029 relative frequency. The class between 60 and 70 has 0.171 relative frequency. So the relative frequency histogram, whenever you're dealing with the relative frequency histogram, the height at the top of each bar represents the relative frequency. Now, the density histogram is a little different. If you look now, the numbers, the same numbers, are now inside the bars, and that's the area. So, if you take a look at this 0.029, that's the area of this bar. Same thing here. The area of that bar is 0.171. So if we look at the density histogram, the area represents the relative frequency, whereas, again, the relative frequency histogram, the height represents the relative frequency. So if you take a look at this rectangle on the right here, which is for the density histogram, the class between 60 and 70, we're going to take that over here. Okay? And if you take a look at the width goes between 60 and 70. So if we take 70 and subtract 60, we get 10. So 10 represents the width. Now, the height of this density, you can see here it goes from 0.005, 0.010, 0.015, and up here the height gets to 0.0171. And therefore, that is the height of that rectangle. So when we want to find the area of a rectangle, it's taking the width and multiply it by its height. Well, the width is 10, and the height is 0.0171. When we multiply that together, we get 0.171, which gives us the relative frequency. So again, the relative frequency is an area for the density histogram of the rectangle, whereas the relative frequency for a relative frequency histogram is the height of the rectangle. So, the area of bars of a density histogram. The following statements are true for any density histogram. The area of each bar is equal to the relative frequency of the bar's class. The total area of all the bars is equal to 1. So, if we go back up here, if we add all these areas up, then that gives us a total area of 1. So let's go ahead and do that. Okay, so we have 0.029 plus 0.171 plus 0.143 plus 0.286 plus 0.286 plus 0.086. And that gives us 1.001. Now, sometimes what happens is that when you find the total area of a density histogram, you might be like 0.001 over, or it could be 0.999. So if it's sort of real close to it in this case, that still means that the area is 1. So again, the total area of all the bars is equal to 1. Okay, next example. The number of hours some college students spend watching television during the summer are described by the density histogram below. You can see here that the vertical axis is the density. So it's 0.05, 0.10, 0.15, 0.20. And then you can see here that the widths go from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10. So for part A, they want us to compute the area of each of the 5 bars in the density histogram. So in order to compute the area of each bar, we need to know that the width of each bar. Well, the width of each bar we determined is 2. This goes from 0 to 2. 2 minus 0 is 2. 4 minus 2 is 2. 6 minus 4 is 2. 8 minus 6 is 2. So we know that the width of each bar is 2. Now we need to determine the height. So if we look at the first one, the first bar has a height of 0.05. So the area of the first bar is taking the width of 2, multiplying it by the height, which is 0.05. And let me point that out with a highlighter. So there is 0.05, there's 2. And 2 times 0.05 gives us a relative frequency of 0.1. Next, we have area 2. Area 2 has a width of 2, and it has a height. If you look at the height, it goes up to 0.10. So 2 times 0.10 is 0.2. So therefore, you can see here that the area of the bar is 0.2. Okay, now for the third rectangle, we know that the width is 2, and we know the height goes all the way up to 0.20. So 2 times 0.20 is equal to 0.4, so the relative frequency is the area of that bar, or the rectangle. Next we have rectangle 4. We know that the width is 2, and we know that the height is 0.10, which we did earlier. So 2 times 0.10 is 0.2. And then for the fifth bar, we know that the width is 2, and the height is 0.05, which we did at the beginning, which gives us 0.1. So again, take a look at the relative frequency is 0.1. There's our relative frequency. There's 0.2, 0.4, 0.2, and then 0.1. Okay, now it says find the total area of the 5 bars. So if we add up the areas of each of the bars, we know that the first bar is 0.1, the second one was 0.2, 0.4, 0.2, 0.1. When we add them all up together, it gives us a value of 1. Now in part C, it says they want us to identify the class that contains the 50th percentile. Well, if you recall here, we have 0.1 is the relative frequency for this one here. This is 0.2. And in between here, this is 0.4. So if this is 0.4, that means that this represents 0.3 and this represents 0.7. So in between 0.3 and 0.7 would be 0.5, which means that the class that has the 50th percentile, or 50%, or 0.50, is 4 to 6. Now in part D, it says what proportion of students watched more than 6 hours of television. So if we take a look here, here's 6, 8, and 10. So this means more than 6. So we know that the relative frequency here is 0.2. And we know here the relative frequency is 0.1. So if we add them together, that gives us 0.3. So 0.3 represents the proportion of students who watch more than 6 hours of television. In part E, it says what proportion of students watch between 2 and 8 hours of television. So between 2 and 8. So we know that we have 0.2 as a relative frequency. We have 0.4. And then we have a 0.2. So when we add those together, that gives us 0.8.